Okay, so I'd like to welcome you to this Developing Fraction Sense presentation focusing on the Grade 3 standards. This is Dr. Henry Borenson. If we should have any technical issues, please stay tuned. Usually we don't have them. So the question is, why don't students hit a home run in their work with fractions? And the answer is they never get to first base. So what does that mean? In a national assessment of educational progress, only 25% of fourth graders in the United States were able to select which of these fractions is closest to 1/2. Can you believe that? Now, if nothing else, they should have at least been able to do some elimination. For example, 2/2 is a whole, that's pretty big. 1/6 and 1/5 are very small. So if they had any kind of fraction sense at all, they would have selected 5/8. So what this example shows you is that here we are trying to teach students how to add fractions, multiply, divide, whatever it is, but they don't even know what a fraction is. And so it all really doesn't make any sense to them. So we would like our students to become experts in working with fractions, but they cannot skip the basics. So what instructional strategies Joanne is joining us, what instructional strategies can we use to enable our students to make sense of fractions? Okay, so we do have a half-day workshop, and so what I'm presenting today is a short portion of that presentation, a half-day workshop on fraction sense for grade 3, and the other half of the day is grade 4. Grade 5 is a full day. Okay, and so most of the ideas that I'm presenting today are taken from the Developing Fraction Sense student workbook A. So let's get started. So Angela, welcome. So let's get started. If the yellow block is a whole, what fractional part is each of the red blocks? So the students will tell you that each one is a half. Then the question is, if you ask them, how do you know each red block is a half? What's the answer they're likely to give us?
There's two pieces.
There are two pieces that make up a whole. Okay, Angela, I assume you can hear me, correct?
Yes.
Okay, great. Welcome. Well, as you can imagine, that answer, there are two pieces that make up the whole, is not entirely correct, because here you have two pieces that make up the whole, but each one is not a half. So what we need to say, we want the students to understand that if a whole is partitioned or broken up into two equal parts, each one is a half. So we need the word partition or broken up, and we need equal parts to make it a half. And we write it like this. It looks a little algebraic. We say if y equals 1, if the yellow block is a whole, the red block is a half. So we then go through the same procedure with the blue blocks. They see that 3 of them form a whole, and the 3 blocks are of equal size, so each one is called a third, and we have this relationship. If y equals 1, the blue block is a third, and similarly, you see that 6 of the green blocks form the whole. So help me out here. What would the red block be if y equals 1? Anybody?
1/2.
If 1/2, and B, the blue block would be?
1/3.
And the green block?
1/6.
1/6, okay? Now, the students learned those relationships very quickly. In 1 or 2 minutes, they realize, they understand and learn and have in mind that if the yellow block is 1, the red is a half, the blue is a third, and the green is a sixth. Now, one of the keys to, let me ask Joanne a second. Joanne, tell me about yourself. What do you do? Joanne, are you a teacher or a home educator? Okay, I'm not getting a response. Okay, let's go on. So a unit fraction is one part when a whole is partitioned into equal parts. So each red, blue, or green piece is a unit fraction. Why? The blue block is a unit fraction because it's one part when the whole is partitioned into an equal number of parts. And you can recognize a unit fraction because it has a 1 in the numerator. Okay, so each of the red, blue, and green blocks are a unit fraction. Now, it's important when you work with fractions that you have not limited to just one model. You want them to get the concept of a fraction. So therefore, we also work with rectangle in addition to fraction blocks. We also work with rectangular grids. So the students need to name each of these fractions. So they need to understand that this whole is partitioned into 6 equal parts. So this blue part is a 6. This is a half. And likewise, they would need to count how many blocks here, and they would know. So that's a way of making sure they understand the concept of a fraction. Here I have this blue block A is 1/15. So in addition to the rectangular grids, we also work with linear measurements. Those are the 3 models that we used in the grade 3 to help them understand fractions. So we need to know what fractional part of the whole is the red piece. So we notice there are 2 line segments. And so the red piece here would be 1/2. Here would be 1/3. Here you would count the number of pieces. It looks like 1, 2, 3, 4, 5. So the length. So they need to do that in order to start to understand the linear measurements. Okay. Okay. Now, what do we mean by the fraction 3/6? How would we define that? What do we mean by the fraction 3/6? We now know what 1/6 is. What do we mean by 3/6? So the fraction 3/6 is the quantity formed by having 3 parts of size 1/6 referring to the same whole. Okay, so this is 3/6 because we're talking about the same whole. So for example, look at this here. Here you have 6 blocks. Here you have 6 blocks, and here you have 6 blocks. But the red portion is not 3/6. Okay, each red is a 1/6 of its own world, but you don't have 3/6. In order to have 3/6, you need to have refer to the same whole. So the language that we use is 3/6 are 3 copies of 1/6. So by using the word copies, you're guaranteeing that all the pieces are the same size. Okay, so this is very common in working with fractions today. 3/6 are 3 copies of 1/6. This assures that we're talking about the same whole. Now, I'm going to show you a 30-second exercise that's extremely simple, but also extremely powerful. Okay? So what I want to do is share my screen here. By the way, if the yellow block is 1, how much is the blue block? Response?
Can you repeat the question?
Yes. If the yellow block is 1, what's the value of the blue block?
½?
Well, let's see. Let's go back here. The red block is a half. The blue block is a 1/3, and the green block is a 1/6. Okay, so the blue block is a 6. So this is, let me share with you a very powerful exercise. So what you do is you grab a bunch of the blue blocks. Each student has a kit of fraction blocks. And you at their seats, you at the front of the room, and everybody counts together. So everybody says, right now we have 1/3, and now we have 2/3, and now we have 3/3. So the students begin to learn that the first number tells you how many pieces you have. You have 4/3. So 4/3 are 4 copies of 1/3. You have 5/3. you have 6/3. And notice that we also indirectly have figured out that 6/3 are 2 wholes, 7/3, and so on. So that's a very powerful exercise to do with the students. And you could do that with the green blocks and also with the red blocks. Okay. Well, by the way, could you text chat? I want to make sure the text chat works. Would you text chat hello? Okay. Angela, hello. Good. And Joanne, would you text chat hello, please? Okay, good. Okay, great. Good. Okay, so now I need your help. If the yellow block is 1, I need to know the name of this fraction. The green blocks represent a fraction. What fraction does the green blocks represent? Would you text chat your response, please? The yellow block is a whole. Okay. Since each green block is 1/6, and here you have 5 of them, this would be 5/6. Very good. And what fraction do the blue blocks represent here? Each one is a third, and you have 4, then you have 4/3. So notice that we're now beginning to see that 4/3 is bigger than a whole. Okay, good. So those are the names of the fractions. Okay, how about here? What fraction is shaded here? So this is a 4 down and 5 across. Okay, this one is 4/5. So it would be 4/20. Okay? And over here, what fraction is indicated by the red line segments? In the first one, 3/5, and the second one would be 4/5. Okay, good. Okay, now, what is the length of the segment in red? Now, the segment in red begins here, okay, and it goes all the way to this point. What is the length of this segment? Okay, I get 5/4. Okay, that's pretty quick. Okay, so the way to figure that out is to first of all look between 0 and 1. This is what we would tell our students if they're stuck, and they will be stuck at the beginning usually. Notice that the segment between 0 and 1 is divided into 4 equal parts. 1, 2, 3, 4. Therefore, each one of these is a fourth, and we have 5 of them. So the answer is 5/4. But I need to let you know that this problem is more difficult than working with grids or with fraction blocks because it's more abstract. Okay, good. Okay, so on the number line below, the students are asked to locate the point 4/5. So when I get to it, just say now or text chat now. 4/5. Tell me when I get to 4/5. Okay, let me start again. Is this 4/5? How about this one? Is this 4/5? We're not sure? Okay, let's see. This point here, since it's 1/5 away from the 0, this is the point 1/5. This is the point 2/5, 3/5. So 4/5 would be here. 5/5 would be here, and 9/5 would be here. So the name of the point gives you the distance from the origin. Okay, so this point is 9/5. Are we together with that?
Yes.
Angela, Joanne, are we together with that? That this point is 9/5? Okay. Okay, let's go on. Okay, now, a good portion of the grade 3 developing fraction sense workbook deals with equivalent fractions. Two fractions are equivalent if they are the same size. So for example, we asked the students 1/2 is equal to how many 6? So how might we do this with 3rd grade students? So what we would do is we already know which block represents a half. Can you text chat, please? Which block is the half? Okay, I'm going to cut out the noise here. We're getting some noise. Mute everyone else. Okay, the red block is a half. The green block is a 6. So this question is really asking how many green blocks equal to a red block. So over here, you see this is a red block. And you see that there are 3 green blocks that equal the red block. So 1/2 is equal to 3/6. Okay, now I have here a 6-year-old that I've been working with, and I have a video showing how she finds the missing number here in 3/2 equals how many 6. So you won't be able to hear her. You'll be able to see her, but I will be her voice. Okay, so let's see. Okay, here we go. I'd like you to help me with this problem. Can you find the missing number? She says she doesn't know the answer. Show me 1/2 over here. Which block is the 6th block? We want to know 1/2 is equal to how many 6? How many green blocks do you need to equal the red block? So she did previous work, so she already knew the answer was 3, and now we're asking her to show how she knows. So 1/2 is equal to 3/6. Let's look at the next example. Okay, we clear the board first. We have 3/2. We want to know how many 6 they form. Please place 3/2 over here. Now, watch what she's going to do. I think she's going to do this mentally. How many 6 do you need to make 3/2? Notice she's doing it mentally. She's using her fingers. She's counting. She said 9. How do you know it's 9? She says 3, and you need another 3, and you need another 3. Okay, so this is the way you see that you want to work with young children on equivalent fraction. It's not a question of giving them rules, but letting them experience what we mean by equivalent fractions. Okay, are we together with that? Everybody's okay? Yes? Okay. So the approach we're using is we're taking a symbolic problem like 3/2 equal how many 6. We're representing the problem using fraction blocks. We're solving it using fraction blocks. And then we provide the answer in symbolic notation. So after working with the blocks, we know that the answer is 9/6. Now, the children also work with equivalent fractions using rectangular grid. So I need your help here. How would you use the above images to determine the missing numbers below? So here we see that 1/4 is equal to 2/8 because there are 8 equal parts here. So how could we figure out how many 8s are in 2/4? Would you text chat your response, please? How can we figure out how many 8s are in 2/4? Okay, Elizabeth is joining us. Okay, so very good. That's the idea. So if 1/4 are 2/8, the students have to realize that this is 2/4. So they could shade it or mentally, or they could put their fingers on it. This is 2/4, and then 2/4 will be equal to 4/8. Okay, 3/4 would be equal to 6/8. And 4/4, which is the whole, would be equal to 8/8. Okay, So this is a nice kind of problem to help them see the equivalent fractions. Okay, and I have a video here of a student. Okay, let me share that with you. Let's see what. Okay, this is also a young student. I think he's either 5 or 6, a second grader. No, so he would be 7 here. Please help me with this problem. The blue is a hole. This small blue part is a fourth. And this blue portion is 2/8. Do you agree that 1/4 equals 2/8? Can you explain how do you know that? Okay, so he agrees that 1/4 equals 2/8. We have a problem here. Any way we could figure that out? 3/4 equals how many eighths? His first answer is 2/8. Would you shade 3/4? So right now we're following with the suggestion one of you made a second ago. Shade 3/4. That's 3/4. 3/4 equals how many eighths? Shade this part to make it equal. Okay, so now he's getting the idea. How many eighths do you need to make it equal? 6/8. Okay, so that's the idea. Okay, very good. Okay, so they work with equivalent fractions then in this manner. Okay, and we do the same thing with linear measurements. Over here, the top line is divided into 2 equal parts, so each of them is a half. The bottom one is divided into 8 equal parts, so each is an 8. So we see that 1/2 equals 4/8, and 2/2, 1/2, and 2/2 would be equal to 8/8. Now, how do we figure out what 3/2 are? How many eighths would be 3/2? How do we do that? 3/2 equals how many eighths? So what the students would have to do, there are a few ways of doing that. One is this is 1/2, this is 2/2, and this is 3/2. So they can either extend the line or mentally see that the answer is going to be 12/8. Extend the line. Okay, very good. Okay, so let me get some feedback from you before we continue. Okay, what do you think about the ideas being presented here? I'm going to unmute and let's see if it's not too noisy. Okay, so Angela, what are your thoughts of what you're saying?
I don't use the fraction box enough, and now I can see why I need to use them to begin with, to begin the unit with.
You say you do use it or you do not?
I did not use them. I used fraction tiles.
Yeah, no, yeah. So I think if you start to use them, you would see they're powerful. They're so tremendous. There's nothing like them to introduce the concept of fractions. Very good. Okay, Joanne, do you have any thoughts about what we're doing so far? Very conceptual? Okay, fine. So I'm going to continue with the webinar here. Mute everything. Okay, now, continuing with the expectations for third grade, the students need to know certain fractions are equivalent to a whole number. For example, we see here that 2/2 are a whole, 3/3 are a whole, 6/6 is a whole. So there's a certain pattern here we want the students to see. And Working with rectangular grids, we see that 2 halves are a whole, 4 fourths are a whole, 8 eighths are a whole. And working with linear segments, we see that here you have 2 halves are a whole. Here you have 4 fourths make a whole. Here you have 8 eighths as a whole. So this idea that n over n equals 1 for any whole number is a very powerful concept that the students are expected to know in 3rd grade. They're supposed to know that 3/3 is a whole, 5/5 is a whole, 10/10 is a whole. And then once they know that, then if they know 5/5 is a whole, then they would know that 3/5 is less than a whole and 7/5 is more than a whole. So this is a very important concept. It may take a little work to get the students to get it, but it's really crucial. Okay, also in the 3rd grade, they need to compare the size of unit fractions. Now, the first time you give this to students, even if they've been working with the pieces, they'll tend to put the less sign here. They'll say 1/3 is less than a 6 because they're focusing on the 6. That happens almost universally. Once you ask them to take out the pieces, they see that 1/3 is bigger than a 6. So the idea we want them to learn, to absorb, is that in comparing 2 unit fractions, the one with the smaller denominator is larger. 1/3 is bigger than a 10th. 1/3 is bigger than 100th. Because if you have 100th, 100 means you have let's say a cake divided into 100 pieces, and one of those is a very tiny part of it, but 1/3 is much bigger. So this is one idea we want the students to know. So this had to do with a unit fraction. They both have a 1 in the numerator, but they also need to know that if you have 2 fractions with the same numerator, the one with the smaller denominator is larger. And they can easily see that if 1/3 is greater than a 6, 2/3 is greater than 2/6. Okay, so this will require a little work, but it's a very important, essential concept that the students need to know. Now, in the Developing Fraction Sense Workbook A, we have a number of enrichment lessons. Okay, so these enrichment lessons go beyond the 3rd grade. But since they're part of the 3rd grade workbook, I'd like to share those with you. So up until this point, we've considered the yellow block to be the whole. However, let's say the blue block is the whole. What would be the value of the green block then? Can I have your text chat response? What would the green block be if the blue block is the whole? So it'll be 1 here. Okay, so that helps the students to realize that the different things can be the whole. How about this one? If the red block is 1, what fraction is represented by 2 of the green blocks? So the answer is 2/3 because 3 of these fit here, and so it's 2/3. Okay, now this is a 4th grade standard, adding mixed fractions with the same denominator, but it's an enrichment lesson here. So let's see how we would do that. So let me share my screen. Okay, so we know that 1 is a whole and 2/3 are 2 blue blocks. And to that, we need to add 1 more whole and 2 more blue blocks. And we want to know how much this is all together. So can I have a suggestion, please? What would you like to do here? So first of all, okay, very good. So first of all, the students might already write an answer because, in other words, if you ask this question to students, some of them will write an answer like this. They'll say 1 whole and 1, 2, 3, 4/3. So some students will write 2 wholes and 4/3, right? Because that's what you could see here. Now, one of you suggested that another thing we could do is we could combine 3 of the blue blocks, make that a whole, and so therefore the answer is going to be 3 wholes and 1/3. So it's 2 and 4/3, or it's 3 wholes and 1/3. Okay, so the students have different examples where they add mixed fractions with the same denominator, and that's an enrichment lesson in lesson number 2. Now, another lesson has to do with subtraction of fractions, so let's try that. So we're going to begin with 2 wholes and 5/6. 2, 4, 5, 6. Oh, you can't see what I'm doing here. Sorry about that. Okay, so we have 2 wholes and 5/6. Subtraction is going to translate to the physical action of removing. Just like addition was combining, subtraction is removing. So I'm going to take away a whole, and I'm going to take away 2/6, and so my answer is going to be 1 whole and 3/6. So these are very simple problems, but it enables the students to see what they are doing. Okay. Now, this is Enrichment Lesson 3. Okay, so this one is a little different. Let's see, we have 2 wholes and 1/3. Okay, here we go. I keep forgetting to show my screen. We have 2 wholes and 1/3, and we need to take away a whole. Well, I have a whole to take away, but I don't have 2/3 to take away. What suggestion can you provide? I need to take away 1 whole and 2/3. So, can I have a suggestion? Okay, so I can exchange a yellow block for 3/3. Okay, so notice that I still have 2 wholes and 1/3, but now I'm in a position to take away 1 whole and to take away 2/3, and so the answer is going to be 2/3. Okay, so again, this is a 4th grade standard and is provided as an enrichment lesson here in grade 3. And we also do some work with division of fraction. So the main thing here is really to understand what this problem is asking us. You can read it as 1/2 divided by 6, but that may not make sense to students. So what we do is we say, we read this as also as how many times does 1/6 go into a half? So now the problem becomes one that even very young children can do, because they can figure out, or as you saw the young girl knew before, that the answer is 3. So 1/2 divided by 6 is equal to 3. Okay, this answer is 3. And it makes sense because 1/6 is a much smaller fraction than a half. It goes into 1/2 3 times. Let's try another one like this. Also from the enrichment lesson. 2 1/3 divided by 1/3. Now, can any of you do this mentally, thinking about the blocks, not using, fancy rules? Can any of you visualize the blocks and answer the question? How many 1/3 blocks go in 2 2/3? And remember, the 1/3 block is the blue block. Okay. So we have 1 whole, we have 2 wholes, and 2/3. Now, one of the things we do that I found helpful is when you work with young children is you have them place this down the way you do here, and then you hold this in your hand and you say, how many times does this blue block, 1/3, go in here? And then they can do it mentally, 3, 6, 8. So the answer is going to be 8. Okay? So notice that when you work with these fractional blocks, the answer could be much larger than the number you're starting with, because you're dividing by something very small, and it goes into it many more times. Okay, let's see. Okay, I think this is going to be the last problem for today. So this is also in the lesson, this is a lesson for concept that's presented as an enrichment lesson in grade 3. So in order to do this, we need to distinguish between multiplier and multiplicand. I don't know if I wrote it down here. Okay, the 2, 6 is the multiplicand and the 4 is the multiplier. So what does that mean? We always begin with the multiplicand, which in this case is 2, 6. So what we have to do is we have to place down 2, 6. And then the multiplier tells you how many sets you need. So you need 2, 6, 4 times. So here's a second time. Here's a third time. And here's a 4th time. Okay? So 4 times 2, 6 is 8, 6. So notice that the students were able to figure out how much is 4 times 2, 6 without you giving them any rules, just simply the definition of multiplier and multiplicand. Okay? And so 4 times 2, 6 is 8, 6, and that's how you do that. Okay, very good. So this then completes the presentation I had for you today. Can I have some feedback from you, please? Let me try to unmute this again. Okay, Angela, your thoughts?
I need to add pattern blocks into my fraction unit. But this just really helps them to see it better.
Okay, Joanne, any comments? Okay, I'll tell you what, why don't let's use the text chat. Okay, so we go from the conceptual pictorial to abstract. Now, of course, the students need to be fluent in doing the calculations, but you want them to have some idea of what they're doing. Also, that way, if they ever forget, they can fix things up. Okay, so let's wrap up the webinar here. We have 2 upcoming webinars. One is for grade 4. The enrichment problems are included there. So here, this example shows 7/3, an improper fraction converted to a mixed fraction. And then we also have a webinar coming up on grade 5, which deals with fraction multiplication. Okay, so those are coming up in the next few weeks. We have staff development on developing fraction sense for grades 3, 4, and 5. We have the Making Algebra Child's Play workshop, verbal problems workshop. The class set of developing fraction sense for 10 students is $65. Each student has their own workbook. Each student has a set of fraction blocks, a bowl, and this is the answer key and teacher suggestions. Okay, so we're now ready for the raffle. Okay, we're ready for the raffle. So I've selected a number from 1 to 10. So if you participated, if you were here for at least half of the webinar, you may take part in the raffle. So please select a number from 1 to 10, and let's see who's the raffle winner. Okay, thank you, Joanne. Okay, anybody else? Okay. Okay, Elizabeth, thank you. Okay, so I think we have a winner. I think we have a winner here. The number is 1, so Angela, you're the winner. Okay, so my office will be in touch with you, but you can also contact us at info@borenson.com. So what we're going to send you this is a copy of the workbook for grade 3, a set of fraction blocks. So you'll see all the lessons that we touched upon today. So thank you all very much. We hope to send out a recording of this session, and if you can join us at the upcoming webinars, that'd be great. So we're going to be logging off. Does anyone have a question for me before we log off? Okay, you're welcome. Okay, wonderful. So have a great day. Thank you.